Hello friends, how are you? In today's topic, we will learn about the workability of concrete, how the workability affects the concrete and the factors affecting workability. First, we will learn about the workability. Workability is how the easily freshly mixed concrete can be placed, consolidated and finished with minimum loss of homogeneity. Means how the concrete can be placed in the construction site or any other construction work without the compacting and finishing, means how the concrete can be placed easily in the beam column or any other work. The workability of concrete is determined how by the fluid is mixed, that is the water cement ratio. This we will learn in the next slide about the factors affecting the water cement ratio. Next point is it can also be defined as the amount of useful internal work to be done by concrete to achieve the full compaction. It means how the concrete without compacted get compacted is also known as workability. Therefore, the workability is property that directly impacts strength, quality, appearance, and even the cost of the labor for placement and finishing the products. Therefore, it workability directly affects the strength of the quality of the structure and appearance. So, workability is important to learn about the workability in the concrete. Next slide. Hmm. Here are some types of workability of concrete. Workability of concrete can be defined into three types. First is unworkable concrete, medium workable, and highly workable. In unworkable concrete, the concrete is also called as harsh concrete, in which water cement ratio is of low content and water content is minimum. See, concrete without little amount of water. As I told now, concrete with little amount of water. Therefore, water content in the concrete is very low. Hand mixing is difficult. So we cannot mix with hand, or it get harder to mix the concrete with the hand. Therefore, high segregation of aggregate means no proper compaction is done. Therefore, the segregation effect is occurred in the concrete. Difficult to maintain homogeneity. Therefore, the proper mix of concrete cannot be done. It causes affects the strength also. Then second is of medium workable concrete, in which is most used in most construction work. Nowadays, the we use medium workable concrete, which is not major unworkable or highly unworkable. Therefore, easy to mix, place, and transport. Therefore, this is the mostly used concrete, medium workable concrete. It is easy to mix, place, and transport from one place to another for any construction work. No segregation and loss of homogeneity. Therefore, no segregation occurs in the concrete casting. Therefore, if we cast cubes or any construction doing that, such as filling of beams, it do not cause segregation and no loss of homogeneity. Therefore, mix of proper proportion may do not cause the loss of homogeneity. And third is of highly workable concrete. This is very easy to mix, place, and transport. It do not require compaction, so therefore it is easy to mix, transport, and also placing used where effective compaction is not possible. Here are some conditions such as we cannot do compaction in the small areas. Therefore, in this high workable concrete is used. Therefore, no compaction is done. High chances of segregation and loss of homogeneity. Therefore, due to high workable concrete, the water ratio in the concrete is more. Therefore, its chances of segregation. Therefore, after placing the concrete, the water will remain up and the coarse aggregates will go at the bottom. Therefore, it can cause honeycombing also in the effect. Okay, then next slide we will convert factors affecting the workability of concrete. Therefore, first is water cement ratio. These topics will learn about in next slide. Therefore, is the some review of the factors. Next is water content. Third is size of aggregate. Fourth, mix proportion, shape of aggregate, surface texture of aggregate, grading of aggregate, use of admixtures, and time and temperature. Therefore, here is the first is factor is water to cement ratio. Therefore, water cement ratio, weight of water to the weight of cement, in which how much the weight of water to the weight of cement is added in the concrete of proportion is known as water cement ratio. Therefore, here lower water cement ratio leads to higher strength and durability, but it may difficult to work with it. So in this point it is told that lower water cement ratio leads to high strength. When the water cement ratio is low, therefore it uses high strength and durability, but it may be difficult to work with it. Therefore there will be, wait a minute, it will be difficult to place the concrete. Therefore, too much water leads to negative impact on segregation and the strength of concrete. As the upper point says that lower cement ratio leads to high strength, but too much water added to the concrete which will give negative impact that will cause segregation and directly affect the strength of concrete. Therefore, the proper water cement ratio in the concrete should be is of 0.45 to 0.6. It is defined by the IS code of 456. Next is water cement ratio is directly proportional to the workability of concrete. It says that when the here is shown when the workability increases, the water cement ratio also increases. Here we can see that as the water cement ratio is get increasing, the workability of the concrete will also get increasing. Here is the graph showing it. The workability is increasing as the water ratio also increasing. Then next it is factories of water content. Here increase in water content increases fluidity of the concrete. Therefore fluidity of the concrete. Therefore the water content is more. The concrete of the fluidity will be more. Provide greater lubrication. Therefore due to more water content, the lubrication friction will be more. Therefore the concrete will be easy to place and more compaction will be not required. Therefore workability, increase in workability of concrete but affect the strength of concrete. Therefore when we increase the workability of concrete, that will affect the strength of the concrete. Here is the most important point. Hence more cement should be added so water cement ratio remains same. Therefore, to make the constant, the water cement ratio should be proper. Therefore, here is given that more cement should be added so water cement ratio remains same. Therefore, not only water content increases is not proper way to increase the workability. That much amount of cement should also be put in the concrete. Hence strength of the concrete remains unaffected. Therefore, both water and cement will be of unequal proportion and the strength also remain unaffected. Then third factor is of size of aggregate. Particles require more water for larger surface area. Hence, the aggregate with finer particles need more water to make it workable. Here, what is told that fine particles, which are small in particles, require larger surface area, have more surface area. Therefore, the water, wait, it will take more water. Hence, aggregate with finer particles need more water to make it workable. Therefore, bigger particles have lesser surface area, so less water will be required and require less amount of waste for lubricating. Therefore, bigger particles have higher workability for fixed water content. This examines that bigger particles should be present in the concrete for the workability of concrete. Thus, large size aggregate are more workable. Therefore, the size of aggregate matters in the factors affecting the workability. Then the next point is of mixed proportions. It is the main important part in the factor of the affecting the workability of concrete. Aggregate cement ratio is the measure of how rich the concrete is. The concrete depends upon the aggregate cement ratio. That means how much amount of aggregate is added to the concrete and cement is added to that proportion of the aggregate is also important. Provide greater lubrication means mixed proportion provides greater lubrication to the concrete which affects the workability and easy it gets easy to for the placement of the concrete. Proper proportion provides better workability. This is known to us. In low aggregate cement ratio makes mix cohesive and hence provided better workability. Low aggregate cement ratio is important and hence provide better workability. Then fifth factor is of shape of aggregate. Irregular shape and rough texture of angular aggregate demand water than more water than round shape aggregates. As we know that the irregular shape is not of a regular shape. Therefore, surface texture of the irregular shape is more porous, therefore it affects the strength and more water is required for the shape of aggregate. Hence, for fixed volume, rounded particles have less surface area of voids. Next factor is of surface texture of aggregate. The aggregate having smooth or glossy texture have less surface area compared to the round rough texture aggregate. As we learnt in the next before slide that the aggregate having smooth or glossy texture have less surface area. Due to it, they have no porous surface area and compared to rough textured aggregates. The poor interlocking action is provided by the glossy textures aggregate. Its use is generally discouraged in the high strength concrete. It affects the mostly in the high strength concrete. The seventh is of grading of aggregate. Well graded aggregate is one with least amount of words in the given volume. If the grading of aggregate is good, the words will be less and hence the higher the workability. This means that the high grading of aggregate should be used and the words should be less. It will affect the workability. Well-graded aggregate tend to fill up voids and get easily workable. If grading is better, there will be fewer voids and excess paste will be available. Therefore, grading should be better provided in the aggregates. It will increase the workability. Next is of admixtures. Admixtures also play a vital role in the factors affecting the workability. Use of admixtures in concrete is the major factor that affects the workability. Use of plasticizers, super plasticizers may applying increases the workability of the concrete. As we know, we apply retarders, plasticizer, accelerators to increase or decrease the workability of concrete. It determines on the weather and the type of condition in which we are constructing the work, and we have to use of plasticizer, accelerator or retarder, etc. Air entering agents produce air bubbles which act as roller between the particles and provide them mobility, thus improving the workability. Next is of time and temperature. Fresh concrete gets stiffened as the time flows. As we know that the concrete gets harder when the time increases and the it water decreases in the concrete. Therefore, we have to increase the workability. The time should be properly managed. This is because some of water used to mix the concrete gets evaporated and some gets absorbed by the aggregates. As the temperature increases, the workability of the mix reduces. As I told that the temperature increases, the time and temperature dependent on the dependent on the concrete. Therefore, the time increases, the workability decreases, and also the temperature increases, the water content reduces, and the workability also reduces. Then these are the factors which affect the workability of the concrete. And here are some methods for improving the workability of concrete. As we learned about these factors, they are dependent on the methods also on improving of workability of concrete. Therefore, increasing water cement ratio. When we increase the water cement ratio, the workability of concrete will also increases. As we know that the water is also act as a fluidity, increases the fluidity in the concrete. Using larger aggregate. Using larger aggregate will require small surface area and hence it will affect the workability of concrete. Using well-rounded and smooth aggregate instead of irregular shape. Irregular shape require more amount of water and cement. Therefore, well-rounded and smooth aggregate require much less amount of water and cement as for workability of concrete. Therefore, well-rounded and smooth aggregate should be used for increasing the workability of concrete. Increasing the mixing time and mixing temperature. As the mixing of the time increases, the workability also increases. Therefore, mixed proportion are getting mixed easily and using non-porous and saturated aggregate. Next is addition of air entering admixtures. Air entering admixtures. Therefore, we learned that the admixtures also play a vital role in increasing the workability of concrete. Therefore, while increasing accelerators, it accelerates the strength on the strength of the concrete and also the flowing fluidity of the concrete. Then next